So in this video, I quickly explain how to formulate the problem. So we start by define the serial variables. So first, the company produces two types of products. So now you can see portable laptops and deluxe desktops. So we first define the serial variables. So I write here. So I do not write all the details, just remember I let XP be portable production quantities of portable model laptop in 1 month, and XD be number of desktops produced per month. So first we define the serial variables, and then we work out the contribution margin for this case. Now we actually can find further information about this. So first, let's see, we have the wholesale price for your computers, for your products, and then in table 2, you can see the variable costs, and the simplest way to work out the contribution margin for this case actually is to calculate contribution margin. So the objective is to find the objective function. In order to find the objective function, then I can work out the contribution margin for each type of product. So for example, contribution margin of desktop is here. So we just use wholesale price 1,500 minus 800 minus 100 minus 20 minus 5, which equals to $575. And the contribution margin of laptop or portable laptop, then that's the wholesale price 1,400 minus 609 minus 90 minus 15 minus 10 equals to $595. Then from this you can write your objective function, which is 500 zeta equals to we probably write maximization. So we write max zeta equals to $575 x desktop plus 595 xp portable. Then that's how we define the objective function. So we have the serial variables, we have objective function. So next step, we try to formulate the constraints. So we move this picture a bit. Move this picture down, and now we can focus on these constraints. So the idea is to work on these constraints in this feasible ration plot or described in the figure, in the graph. So we take the simplest one. So this curve, you can see, I use the color. So this curve is assembly portable. So if we take the portable serial variables, then this should be less than 2,000. You can find this value here. So this actually this boundary. And then we have this curve, the assembly desktops. So its XD should be less than 1,800. So pretty straightforward. Then we have another two boundary constraints, board staffing. How do we decide this? So the commonly used method, there are a lot of methods for you to find the equation for a constraint formulas for this boundary condition. So I introduce one method. You can put any value xp, xd in this plot. So for example, there is a point, then you know this is xd. Correspondingly, you have xp. then you know actually this extreme point, corner point values, then you can use ratio relationships. So for example, this line over this line, the ratio should equals to this part over entire part in the triangular. So now we use this condition, we can work out equation conditions. So basically we have xp, this length, it's an xd, so actually xd over this range, so which is 3000 equals to, actually this part is 2500 minus xp divided by 2500. So if you rearrange this equation, then we get the constraint for your board staffing, which is xd plus 1.xp less than 3000. So similarly, I change a color to look into this boundary condition for case productions. So for case production, similarly we choose 1.xp xd by using the similar method. So you have this, and so now we can see, now you can use these new relationships. So we have this ratio over this ratio equals to this line to this line. Sorry, it's quite messy, cannot see very clearly, but so here you basically have a new relationship. So you have a xp over 4000 equals to, so this ratio is 2000 minus xd over 2000, and then rearrange this relationship, then we get the constraints, which is 2 times xd plus xp less than or equals to 4000. So that's how we actually find all these constraints. So now if I take an order of these constraints, so we try to name them. So we have a constraint 1 here, so we have a constraint 2 here, we have constraint 3, constraint 4. So that's how you formulate this problem. So do not forget you have a non-negative constraint. So both decision variables should be should be non-negative. So we put all these results together, then we can actually continue to write the third step. We found all the constraints. Then this problem subject to the constraint 2 times xt plus xp less than 4000, xd plus 1.2 xp less than 3000, then xd less than 1000, xp less than 2000, and xd xp greater than 0. And if we need some verbal explanation, then we have case production constraints, we have board staffing, we have assembly, desktop, we have assembly, portable model, and this non-negativity constraints. So now you have a completed model. So if we continue to look into this model, now let's see, actually in the text, in the case, they actually mentioned following up. So following up on controller's comments, the production manager suggests a way to increase production. So they can increase production if we outsource some of the board staffing to the subcontractor. And we could supply the boards and the components and pay the subcontractor some negotiated price to staff each desktop board and a negotiated price to staff each portable board. So that's actually give the option to the company. They can build a model with outsourcing. So now we try to do this, try to formulate this model based on what you already have. So we just write, we can do a LP model with outsourcing option. So now from the case question, above question 4, so I can tick the question 4, above this question 4, now you can see there is a paragraph to state if the company now choose to outsource some of the productions. So assume that the subcontractor is going to charge 110 and 100 for board staffing. So in this case, we need to recalculate the contribution margin for your problem. So previously we have the cost for so I just try to find the initial information for the board staffing. So now you actually can see you have board staffing cost 190. Now if you outsource, then you actually have 110 and 100. So slightly more expensive than produce in-house. So with this updated outsourcing cost, we can actually rework. So we can rework our contribution margin for the outsourced products. So you actually can calculate. So if you produce in-house, we have the contribution margin. If we name it as RD, which is 575, and RP is 595. That's what we have calculated before. Now, if you think about outsource, then your outsourced products contribution margin actually will be slightly lower, so will become 565 and 585, because the staffing cost actually is $10 more expensive for each. So now you have a new contribution margin, and apart from the previous the decision variables XD and XP, we need to also define new decision variables for your outsourcing quantities. So I do not write it, just stated here. XD0 is the production outsourced product quantity. XP is the outsourced production of so we can rename it. So XD0 is the desktop quantity of desktops with the external staffed board. So basically including outsourcing. So this is portable models. Quantity of portable models with external staffing boards. So now you have actually four decision variables defined. So I cannot make it smaller. Now next step, we work out the objective function. In this case, you can just write a new objective function, which is to maximize zeta equals to 575 XD plus 95 XP plus 565 xd0 plus 585 xpo. So that's our new objective function. The constraints also changed. So the main change actually is in your total productions. And so the board staffing total production in-house is not changed. So now let's work out the constraints. So now the question is how the constraints. So if we see these are the original constraints without outsourcing. If you have outsourcing, actually the purpose is to increase your production. So apart from XD, XP, you actually also need to provide components or the processing jobs for your case production, assembly desktop, and assembly portable. So in this case, you actually will have a new, do I delete this? No. So use this. So now for each individual constraints, you actually will transform them into for case production capacity. So you have original, change your color. So your original have 2xd plus xp for your total production. Now you actually outsource some board staffing in order to produce more products. So for these more products, you actually also need to provide case production cases. So in this case, you actually still have the fixed capacity, but you have a higher demand for this department. And then for the second constraint, xd plus 1.2 xp. So this was original board staffing constraint, so nothing changed here. The extra board actually from external subcontractor, so we don't change this one. And then for your assembly, and you actually need to consider also the extra products, extra products with outsourced or with external board. So this actually should be less than 1,800. And also for the XP, you should also have XP plus XP0 for portable products, still 2,000. And now you have XD, XP, XDO, XPO, all greater than 0. So that's how you write your model. Now we have decision variables. So if I name here decision variables, objective function, and constraints. So now we have basically two types of models. One is without outsourcing the board staffing production. One is with outsourced production. So we're going to use both formulations in our case discussion on Thursday.